Alright, so I've been asked by quite a few people how I level my bed. This is not anything new, and if you're already good at leveling your bed, don't worry about it. This is specific to the Prusa MK3. Will also work for the Prusa Mini. Uh, I'll be putting this, I have files up on Thingiverse that I use, but we'll get to that later. So, just general process, I had to do a rebuild of my nozzle. So every time I do a rebuild of the nozzle, I recalibrate the bed just in case the build of the nozzle is slightly off a little here or there. So this will be the same as if you just built your printer. What would you do? So in your menu here, you can either go to hardware setup if you have not set up different sheets. But for me, let's go here to settings, and then under settings, you'll find hardware setup. Steel sheets individually. If this is the first time you're running your printer, this will just be when it gets to the hardware calibration. This is the same thing. We're going to do first layer calibration, and we're going to start from 0 since this is showing you how to get the best bed level. So starting from 0, this particular one would be PLA. So first we've got to wait for the heater, for the printer to heat. I'll do my best to edit this video later. Make sure your bed is clean, and make sure you are using 100% isopropyl rubbing alcohol. 90% or 70% has additives that can cause your bed to lose its tackiness. If you are having problems with your print sticking after you've done multiple prints, then you may need to wash the bed with soap and water, especially if you're using PLA. PLA leaves behind like a small sugary coat, and that sugary coat can reduce the stickiness of the PEI. So give a good wash with hot water and dish soap, and then once you dry it completely, put it back on your bed and wash it again with 100% isopropyl alcohol. The 100% is more important than you think. So like I said, if you're using store-bought 90% or 70%, that is actually going to negatively affect the stickiness of the PEI, and you will have a hard time getting print sticking no matter what you do. If after a very long time of printing neither of those things work, you can always try using acetone to clean it rather than the isopropyl alcohol for a single cleaning. The isopropyl will actually over time make the PEI brittle, so you don't want to use that very often, but it can resurface the PEI. If the acetone doesn't work, the very last step to take is to get something like a 2000 grit sandpaper or really low grit steel wool, and give your bed a very gentle rubbing while it's cool. You don't want to do it while it's hot. So those are some other troubleshooting steps to getting things to stick, but this is the idea of just the first layer calibration. So we're assuming your bed is clean, everything is good, and parts should be sticking no problem. Alright, so the first thing it'll do is it'll auto home, and then it's going to measure your bed. It's called mesh leveling. So it's going to measure your bed to try and get your bed as close to level as it can measure using the sensor, whether you have a touch sensor or a Pinda or Minda in this case. Those particular sensors are not on all printers, so if you do not have a Prusa, it won't be doing this step, which is fine. But you definitely want to make sure your bed is as level as you can, that you've manually leveled your bed. Alright, Once that's done, it's going to return to the beginning and it creates a small purge line. The purpose of this purge line is generally to equalize the pressure inside the nozzle, also to make 100% sure that your printer is printing the correct filament if you've changed colors. You'll notice this is not really sticking when it first starts. See how that's loose? So we've got to start lowering the printer. Because this is a negative number, the larger the number is, the more likely it is that or the closer you are to the bed, right? The closer the distance is with the larger the number, because they're negative numbers. So when you're doing the bed level calibration on a Prusa, it creates this zigzag pattern, right? And what I do is every time it makes a pass, I give it a touch. If it's still not done, I try and go down at least a whole 0.1, if not a 0.2, if we're not even close. This particular printer does have a very large distance for some reason when I built it. This one actually has the largest distance, which is also the reason I chose to use this one in the video, is because a lot of people are too afraid as that number gets bigger that something bad is about to happen, right? And that is something that we don't want you to get into. So the very last portion of the zigzag patterns is it prints a small little square. Being as I cannot see the square, how well it's stuck, we're going to start there, and we'll have to do the Z layer calibration again once it's finished. And this is very common to do your first layer over and over and over, as we're trying to be very precise in how we do it. I always start with this particular pattern on the Prusas as it comes stock, and it prints a lot faster than the final pattern I use. If you are using a different printer, just start with the final printer that I use, but the same concept matters. So we're getting kind of close. You can see that square sort of stuck. So this is where we're going to first talk about Z height and how it affects your prints. You'll notice as I begin removing this, of course it's being finicky on me and I can't get my fingers to grab this filament. As I go to remove this particular layer, see how it comes apart in strands? That means it's not squished enough and each layer should adhere to each other. So that's not going to work. So because I touched the bed with my hands, we're going to go ahead and give it a squirt, 100% isopropyl. Give it a wash again so that my oils from my fingers are not on the bed. And we're going to do that process again. So for this particular one, we go down to settings, just scrolled past it, then hardware setup, steel sheets smooth, first layer calibration, and now we're going to continue from where we were this time because we've already done some of the lowering, but it's not lowering enough. Now because it's not stuck together at all, I will generally try and go down another full 0.1 from where it was at on the first strand, and we'll do 0.1 at a time until we start seeing some squish. Alright, again, every time you do a print, it will mesh level the bed. That's part of the features of the Prusa, so this is totally normal. It's just something you have to go through every time you do a print. I'm at 923, so I want to go, we'll probably go all the way to 1050 because we know that it wasn't sticking. So there we are at 1050. So now that it's moving past, I check and see with a very gentle touch these are starting to stick. So I'm going to go ahead and let it finish at that 1050. And we'll see where we are at when it prints that square. Like I said, I like using this calibration pattern to start with because it prints so much faster than the main calibration pattern that I end up using to fine-tune the printer. The main calibration pattern takes a little over 20 minutes to do the entire thing, where this just takes, a minute or two to finish. So I always start with this one because it's a lot faster. Again, if you don't have this on your printer particularly, like I said, that's fine. Just start with the pattern we'll be doing here in a few. Alright, so as you can see, the entire pattern is now stuck to the bed. So we're going to remove it starting here from its beginning. And the idea is I want to be able to see that this string is completely stuck together all the way through the entire print, zigzags back and forth during the removal. Oh, I broke it there. Not a problem, that happens. But it wasn't because it wasn't stuck together, just because it was stuck to the bed too well. Alright, now when we get here, this is what we want to check. So let's get this in the picture here. So we have this little square that it is printed. This little square, you can see all of the layers are completely stuck together. They're completely smooth on both top and bottom. There's no wavy pattern. I can't easily pull them apart. So now we're pretty close to where we want to be. So now we're going to go to our fine-tune print pattern. Now, because I, again, touched the bed, we want to spray it with isopropyl alcohol. This is something you should be doing every time, especially if you touch it with your fingers. If you are removing your prints with like a painter's scraper or spade or screwdriver or something of that nature, this is something you probably get away with doing every couple of prints, every 3 prints. But if you touch it with your fingers, you want to wash it every time. Alright, so now we're going to select from the screen, print from the SD, and we're going to do this MK3 PLA bed leveling calibration. So let's fire that up. This is what I use to fine tune and really get my printer to the right first layer. Now, it's important to note on this particular pattern that it takes a while, and I highly recommend on the first print you basically babysit it. It's going to take about 20 minutes. On this one I also use a custom G-code. This particular G-code comes at the beginning of the Pretty PLA from Chris Wakaki. The Pretty PLA profile has a great starting G-code, and I actually copy and emulate it for a lot of my prints, but it lowers the temperature for the bed measuring. So that way your nozzle is not quite as hot, it has less of a chance to mark the bed to mess up the PEI. It also prints at a slightly higher bed temperature, which increases the chances for adhesion, and it also allows the bed temperature and the hot end itself to sort of regulate the temperature on the pinda. The pinda having a steady, consistent measurement, in other words, for it being warm, it will get a better measurement. So having it start at these particular temperatures for the length of time that it takes has a better chance of warming up your pinda, and then not having the nozzle so hot that it has the chance to melt the PEI or mess up your bed in any way. So again, it will start by homing and then measuring the bed. Alright, now that it's measured the bed, it will go back to home and it will heat the temperature to its printing temperature. Alright, once it gets to temperature, it begins its purge line. And we begin the print. So this is where I begin watching it. I do print it with the outside skirt. The purpose of a skirt in general printing is it surrounds the bottom layer, creates sort of like an air barrier, if you will. It also allows your nozzle to completely purge whatever previous material or color that you had in it when you are switching between different colors or materials per print. It gives it a time to go all the way around your print, get rid of any excess that might be in there, so when it starts printing your actual print, you have a pure color. And like I said, it also creates a small airflow. If you make your skirt as tall as your print, or at least an inch or so up a taller print, it actually creates a barrier so that you do not get a breeze that cools the bottom few layers that you want to stick to the bed at too high of a rate, and then you have it peel up or warp. So it's a way to help fight those things if you're having those issues. So here you can see it begins printing the outline, and I watch this all really closely to make sure it's all sticking to the bed. Make sure that skirt is sticking right near the edges to the bed, making sure each of these lines and circles appears to be adhering well. Everything is looking good. When we start getting to infill, I'm actually going to adjust the printer up and down a smidge, or I may do that in future individual prints, just to show you the kind of thing you're looking for. So it looks like I may have guessed pretty close on this one. We're getting a great adherence. Yep, you can see all the edges are adhering well. See if I can light this a little better. Yeah, that looks better. You can see that much better. So all the edges are adhering quite well. All the circles are coming out crisp and clean. None of the edges are pulling up, causing these to be ovals. So why do I use this pattern? So this pattern checks all the areas and edges of your board without having to print one solid flat piece. So it saves both time and filament because you're not printing edge to edge in a solid line, but you're printing something large enough in each area, you should be able to get a good indication of exactly how the adherence is in your bed. It will let you know that your bed is level in case you have any spots that are higher or lower that need to be leveled, especially if you're using something that is not a Prusa and you have to manually bed level anyway. This is a great way to test your bed leveling as well as the quality of that first layer in all areas of the bed. appearance here. Alright, we're beginning infill on some of these smaller circles here. And like I said, I'm going to be adjusting the Z height of the printer on some of these so I can try and illustrate in just a single print certain things you are looking for. So, but we'll do that on the larger circles because it'll be easier to see than on the smaller circles. Alright, so by pressing the button, you can go to Live Adjust Z, and this is where you'll be adjusting that level height on your Prusa. Every printer is that slightly different. So we're in our very first circle. I'm going to let it finish at the height that it's at. So this first circle is at negative 1.05 or 1050, whatever, however you like to easily remember numbers. This is the boring part. So definitely feel free to grab a drink of water, whatever you need. And I also try and edit this. Should be noted that the same process can be used whether you're doing the textured sheets or the smooth sheets. A smooth PEI sheet is thicker than the textured powder coated sheets. So on the textured powder coated sheets, you will actually have a larger number than you do on your smooth sheets. And it's usually somewhere between 0.1 and 0.2. So if this was a textured sheet, as you can see right now, we're printing at negative 1.05. It could be 1.025 or even possibly a little bit greater, but they're usually somewhere between 0.1, so that would be, instead of being 1050, it'd be 1150 to 0.2. That could be as high as 1250. and I've actually seen some be even greater. So don't be afraid when you're printing on your textured sheets to know that you'll have a larger number. Alright, it's still filling in small circles, so when we get to our next big circle, we're going to adjust this number. Again, I want to be able to illustrate a few different things to you all at once. Alright, so I want to have a large circle that will illustrate what it looks like when your nozzle is too close. So we're going to go up, I'm going to guess about 2 of these, and we're going to go to 1250. And that should be enough. There's 12. To get the effect that I'm looking for. Fortunately, these circles are not big enough for me to really see under it, so I won't know if that is true until it finishes printing. In which case I may need to go lower again, which is fine. Like I said, thanks for bearing with me. I know that this is the part that isn't fun, but if you really take your time bringing in this first layer calibration to make sure your bed is level and your first layer is spot on, you will have much better prints in the long run. We didn't quite get what we were looking for in there. Let me get a better light so I can see right on it. We're getting the effect I wanted. Yes, we are getting the effect. Could be a little bit greater. So I might turn that up just a little more to make sure that you can clearly see what I want to illustrate. Again, it's filling in small circles, so we're not going to make any adjustments, so it gets to the large circles because it's much easier to see. Another small circle. We're on to our next large circle. So to make sure that I can see really what I want to see, we're going to go all the way up to 13 on this one. That way I'm positive I get the effect that I'm looking for. So remember our first circle here, So 1050, 1250, 1300. And then these ones will adjust down to something more in the range of what we're looking for. Thanks for your patience sticking with me. We have 2 small circles and 2 large circles left to go, so we're in the home stretch. But as you can see, we started getting it to stick about 950. I'm all the way up to 1300 at this point, and you can see it's not damaging the bed, it's not causing any issues. So lowering that Z height is not something to be too afraid of, as long as you're going in 0.1 or 0.05 increments instead of going at 1 point increments, going from 1 to 2 or 1000 to 2000. That is a huge difference. But going from 100 to 200 or from 50 to 100, those are very tiny increments. So your chances of doing any kind of damage to your printer are very small if you're going in small increments at a time. Alright, we're going to be filling this one, the large one. So we're going to go down. I'm going to turn this one down to 1150, and I'm going up, not down. Pay attention. So we're going to turn this one down to 1150. A little bit bigger than the 1050. And then for our last circle, we're going to go all the way down to 950 so that you can see everything in a slightly different range. So that way we'll have 950, 1050, 1150, 1250, and 1300. Alright, so why bigger and smaller circles? So the bigger circles are the most important areas of your bed, right? They are the 4 corners and the center of your bed. So that's why the big circles print there. The smaller circles in between are the points, basically measurements in between those 2 measurements, just in case you have a warp in your bed. If you have something that is bent or screwed down incorrectly, you could have a bow or a bend in your bed, and it will let you know if there's a dip or a rise in that particular area. But if the 4 corners in the center all print well, and everything in between seems to stick, your bed is basically level. You really don't need to measure every single tiny little square inch of the bed, and like I said, this will be much faster and use a lot less filament than if you were printing one flat sheet over the entire bed. We're on our last small circle now. we're on to our last big circle. Remember, I told you we were going to go up to 950, so you guys can see the different heights. The info screen, because that's boring to watch. We only have about 2 minutes left. Definitely in the home stretch. Again, thanks for sitting through this. I know it's boring, but I'm not a great video editor. If I did figure out video editing, then this is not that long. If I didn't, I just uploaded this raw, and you all are here for the long game, and I appreciate it. Alright, so here's where the real test begins. Another benefit of the Prusa is that the Prusa has a removable bed, which is fantastic, right? And as you can see at a quick glance here, all of these have stuck effectively to the bed. So any of these print layer heights would give you a different outcome. And as you know, we've gone from 950 to 1300, and everything appears to be stuck to the bed. So how do you know what is a good first layer on your prints? So we're going to start here. So this is our lowest one, 950. Looking at it here, while it's attached to the bed, not much to write home about, and everything is good. So we're going to remove these with spades so that they're nice and flat when they come off. So using a spade here, trying to get right under the edge. I'm always probably more gentle than I need to be, but here's our first circle. So at 950, you can see it did stick, but these individual layers, see how they're not stuck together. These individual layers, let me make sure this is in camera here so you can see it. There we go. These individual layers are not stuck together at 950. See how easily they separate? That means that number is too small. The nozzle is too far away from the bed, right? So that's what 950 looks like. So over here, we have 1050. You can tell while it's stuck to the bed, it doesn't look much different, right? So we're going to pull up 1050 here. Again, I'm always a little more gentle than I think I probably need to be. I just really don't want to mess up that PEI. All right, so we've got that scraped up. I want to make sure that's a nice solid piece. So here, we're going to look at the back. See, nice and smooth, nice and shiny. Let's test that layer adhesion. Okay, these I cannot pull apart easily. That took a lot of force to break that apart. We did a nice smooth glass. So 1050 is a measurement we want to remember, right? So as we moved across, we came here to 1150. So you can see now in 1150, see up at the top, we're starting to get weird, like small little scratches, these strange designs in here. It's not completely smooth, right? It's not entirely smooth. See how you can see that? So that is when you can start seeing those kind of artifacts, you're probably starting to get too close to the bed. But let's peel this bad boy up here. All right, so we're under. Okay, there we go. I'm just going to break those so we can get just the large circle. So if you look on the back, you can see, again, we're fairly smooth, fairly tight, and the lines are incredibly well stuck together, right? But we're starting to get this weird artifacting, and because we have this weird artifacting on the top, we're too close, right? So it's not optimal with these weird artifacts. So remember, we kept going deeper, so this one in the corner here is 1250, and you can see those artifacts even deeper. And 1300, you can really see those sort of waves. I just refer to them as a wavy pattern, right? But they're parts that don't print very well. But even at 1300, right, we get in here and peel this off at 1300. You see you have a nice smooth surface on the back, but you can kind of see where those artifacts are coming through, and they are incredibly well stuck together. So even though this is way too close to the bed, I'm not sure if you'll be able to see this, but it's actually a texture to it. It's been squished so much in those waves. You do not have a smooth top part of the bottom layer. So this is way too close and is going to cause issues later on in your print. So if you recall, 950 did not stick, right? Oh, I have it backwards. So 950, the pieces did not stick together at all. At 1050, the pieces stuck together pretty well, and at 1150, they were stuck together, but we had some small artifacts. So somewhere between 1050 and 1150, 1050 being very good, but you can see on there, let's get this in the camera there, you can see on there that you still see a little bit of lining in there. So maybe 1065 or 1075 might be right what we're looking for, but you're going to play around on the next one between 1050 and 1150 to get that really dialed in. I don't think you need to see an entire another video to get the idea of the process, but you keep repeating this print, and as you can see, I changed on all of these to try and see where it was. Now that I know it's between 1050 and 1150, I would print this again, starting at 1050, and instead of going up by by hundreds, I would go up by 50s or 25s even. So I'd go like 1025 or 1025, 1075, 1050, 11, and then let that print at 1125. So we would be printing between 1050 and 1125, right? So 1050, 1075, 1125, and we know 1150 is too big, so probably these both two would be at 1125, right? And then I would check each of those to see which looks the best. Once I have whichever one looks the best of those different areas, again, 1050, 1075, 1125 on both the top, see which one looks the best of those. Then I would reprint the entire thing at that setting, leave it alone, peel it all up, and make sure everything looks good. Once you have that done, your first layer is complete. Alright, I hope that helps and makes sense to everyone. I'm going to go ahead and shut this off and see about getting it uploaded.